Greeting, giant nerds. We are looking at the discriminant today. Very exciting. Try to solve this quickly, and we'll talk about it in a second. Go. Okay. There's a couple of ways to solve this. One is quadratic formula. Another one could be graphing. And so here's a graph. I put it in a graph. It looks like there's a point there and a point there. That should be kind of the same thing you got here, right? 2 and also a third. Those are intersections of the x-axis, but it could be, going in, you don't know just by looking at it if there are solutions, because sometimes there's not. Because who knows, this could have been a C value like that, and if the C value is too high, whoop, no solutions, right? It's not touching the line. Or if it's just right, you get one solution. Yo, come cameo, come say hi. It's a math video.
We're talking about the discriminant. Super sweet.
Okay. that was random. Can you make sure you turn the light off?
Will do.
Okay.
Turn the fish off?
No.
I'm hiding in the science because it's hot out and it's air conditioned. Okay, so it might not have a solution. You don't know by looking at it, right? Let me give you another example of that. If you were bungee jumping, and this is you because you're smart enough not to go bungee jumping and just to observe your stupid friends falling off. So depending on the bungee and the weight and all that stuff, your friends could pass your eye level. Usually they go, ah, and you see them one time falling past you, and you're like, oh, there they are, right? Ah, and the bungee catches, and then comes back up, right? And they go past you again. 2 solutions, right? If the bungee's perfect, right? And their weight's perfect or whatever, and they go, ah, and they come down, and they're at your eye level only once, and then they go back up. Or if they're lightweight or like, I don't know, haven't eaten breakfast, so they don't have a big belly full of breakfast, they go and stop before your eye level. And so they could cross twice, they could cross once, or like touch once, or they could not cross, right? Obviously, they could bounce a bunch of different times, but then it no longer is a quadratic, and it kind of breaks the idea. Either way, we want to be able to talk about the number of solutions. This has obviously, how would you know? It's not obvious. It has 2 solutions. It touches the x-axis twice. This has no solutions, no touchy. This has 1 solution. Actually, it's 2 solutions in the same spot. One way we can find out is called the discriminant, and it's the inside of the radical in the quadratic formula. Which you want to sing with me? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's the stuff on the inside. You don't even need the radical to tell you about the discriminant. And I'll kind of here's the details, but I'll tell you why in a second. So maybe you want to write that down. Here's how it happens. You could break up the quadratic formula a little bit differently. You could call this, I'm going to break this up into 2 fractions. This, so negative b over 2a, and plus or minus all the rest of this garbage. Oh, shoot, also still over 2a. b over 2a plus or minus root, who cares, on the inside, minus 4ac, still all over 2a. So, if you think about it, and I hope you do, this piece, I think you've seen this before, that this is the axis of symmetry. So this tells you where the middle is. And to find the X intercepts, you start at the middle and you go positively one way for a little distance. Let's call this red. We go this way a little bit of a distance. Zip, and you get one of your X's. And if you go the same amount but in the backwards direction, zoop, you get the other intercept. So, if you know that this is some positive number, it means you're going a positive direction to find the X intercepts, that means there are X intercepts. However, if the guts in here are 0, square root of 0 is 0. 0 divided by who cares gives you 0. So to find the two intercepts, you started at the axis of symmetry here with negative b over 2a, and you go one way 0 and the other way 0, meaning that both are right there, right? You're like, let's find the axis, the X intercepts, and you don't have to go anywhere. They're right there. If this thing is 0. So 0 as the discriminant gives you only one solution. Just means the two of them are in the same spot. If you have a positive discriminant, it means you're going a positive direction one way and then the other. And to find, so there are two solutions. And if this is negative, if you had like negative 25 inside, it gives you a hint that there's something wrong because you can't take the square root of a negative. And so this piece says that something's wrong. That means there are no solutions, or there's unreal solutions. So negative in the discriminant gives you no solutions. Yeah. So hopefully you can look at this and say this has two solutions. This has a positive discriminant. Yeah. This has no solutions. This has a negative discriminant, and this one has 0 as its discriminant, right? And you would find that by taking this discriminant, this b squared minus 4ac, that's the discriminant. This is a, this is b, this is c, plug them in, right? So this is 5 squared minus 4 times negative 3 times 2, which is 25. This is 12, 24, and it's positive, plus 24. At this point, I don't even care what the number is. That has no value. It's just, is it positive or negative or 0? I know it's going to be positive, which gives me two solutions, right? So you're just peeling A, B, C out and dealing with this little piece. I think you've seen that before. Cool. Try that out with your practice problems in the discriminant and be the discriminator. Okay, bye.